Hi, everyone. It's 4 o'clock, about time to get started. If someone could get the door, that would be nice. My name's Justin Ryan. I work at Netflix on the engineering tools team. That team is specifically there to help the other teams, right? So I'm not doing other people's builds per se. I'm writing the tools so that they can do their builds. Lets us think a little bit higher about how we want to do development at Netflix. The thing I'm going to be talking today is the Netflix build language. There's a lot of meat to this presentation, more technical stuff. I had the pleasure of speaking last year at the Gradle Summit, which is a much more abstract talk about how you could do dependency management and stuff. This is not that talk. This is going to be more meaty. And I think that's perfectly fine for this audience. If you look at the other talks, there's an Android talk and some Maven to something. So get rid of the Maven people, get rid of the Android people. We got the real Gradle people here, OK? That's you. You're in the right place. Netflix build language is sort of a long word, so we shorten it to, we took the NE and the BU and the LA, and we made Nebula. We even got a logo. We know that we're big enough to have our own custom language, the way we like to think about how builds should work and stuff. And so we sort of accept that and say it's our own build language. We get that and stuff. And documentation-wise, right? If I can have Gradleware add documentation or have the kinds of people in the audience here writing plugins, means I don't have to. And we really do believe pretty strongly in that, which is sort of the basis of this talk and how we can sort of help you guys write plugins. And so make it a little bit of a two-way street. Netflix used to have a legacy build. It was Ant, Ivy. We migrated to Gradle. And there was a few reasons. We didn't just do it blindly. We did do a little bit of homework and research and stuff. I get a question pretty much every week from a new employee, why can't I use Maven? I have some pretty solid answers why we can't. And some is just legacy. It's not that I don't like it. I probably would have chosen it if we didn't have some of the legacy issues. But our hands were sort of forced, having Ivy repos, some of the features we're using, some of the behaviors people are used to, right? Having tasks, lots of tasks depend on each other. And I think if enforcing a rigid life cycle on people, like you get a Maven, could be sort of troublesome for like my audience, my customers. By the way, quick question, or the first question of the talk. Who's watched House of Cards? OK, we're going to get some references then, good, if I make it in there. So Gradle sort of really fit the bill for us, given the possible options that are out there. Like, we do truly feel that Gradle is the best build system for the JVM right now. Not to say it doesn't have any rough edges, and I'm happy to talk about those too, but this is the horse we want to put into the race. Most of the focus on Gradle maybe more recently has been on Android, right? You see if you follow Stack Overflow questions for Gradle, you're going to see a lot of Android questions and stuff. We haven't moved that team over to Gradle yet. We haven't moved a lot of teams at Netflix over to Gradle. The primary focus that I'm going to be talking about here, JVM-based languages, Scala, Java, Groovy, those kind of languages. Things that we could have done in our Ivy build, but were hard and we get for free when we go to Gradle. Given that, what we're really trying to do is use Gradle for resolution and make some code quality checks and publishing, right? Get a jar, get it up there. From there, we can have other systems, right, and different deployment pipelines. I don't play in that space as much, but we're very happy to have Gradle act as a sandbox for those people. So if teams want to go through and add a whole bunch of custom deployment logic, being in a Gradle script is a great place to be. You can add some dependencies. You can call external places. I don't do that as much. So the focus here is on building the code and dependency management. To make Gradle easy, right? So people are pretty used to having Ant on the command line. They write Ant build, and they were happy. Their Ant files were quite small. So as we were trying to make the migration over, we wanted to have that same experience. And as we try to keep the experience simple, we found, well, actually, we have to patch Gradle. And we have various reasons for it. We're happy to do it. The onus is on us to keep up to date with Gradle changes as they go on. One of the examples would be there's a bug in Ivy when you're doing an exclude by, like, I think it's like artifact name or something. There's something weird that works perfectly fine in Ivy, and we went to Gradle. Gradle did it correctly, and that broke us. And it excludes everything with the org Netflix. So that was sort of didn't work for us. So we have to, that's a patch. That's an example of a patch. There's a few things where we might not get it in Gradle for a while, and that's fine. We'll be excited when we get it in the core distribution, but we'll just maintain some patches. So we do have a patch Gradle. And I sort of covered this material because I think a lot of people have to deal with this. If you're trying to use Gradle out of the box and it just doesn't have everything you need, I'm trying to show, sometimes you need some coaxing to fit your environment. And I think that's perfectly fine. And I'm happy to share any of the work I've done on it. I'm not going to focus too much on it, but I'd say go for it if you need to. Another example would be a custom distribution. This gets pointed out every once in a while. Like if you want to have an init script. So that's a classic example of what we do. If you're running our Gradle, we want to have you point to our artifactory. The best way I found to push that out is to have some init.gradle scripts running in there. So that's one of the reasons we make the custom distribution. And since we have a patch Gradle, those two things go really well together. But you got to get the custom distribution out to people. So we also have a custom wrapper. The custom wrapper, maybe a wrapper would have been OK just on its own, but there was some other stuff we wanted to do in there, like setting environment variables, like maybe some default memory settings. Right? If no one set a Gradle ops, we might have a preference to give you more memory on your build. So that was another place that we wanted to play. We wanted to play in all these spaces to give the end user experience, or have it look pretty good. What that means for a developer at Netflix is this is what their build file looks like. Apply plugin Nebula. That's like their single entry point to say, yeah, I want that stuff. The reason this is possible, and there's no build script going on either. This truly is a working build at Netflix. Is that in the init.d, not only do we add Artifactory, we added our jar that is specific to our build. You don't have to use it. You don't have to use our plugins, but they are there in the build script class path. So it makes it easy for them. We do pollute their build script class path, so hopefully we don't put anything too bad in there, bad version of ASM or something like that. Generally, we've been safe so far, so we'll keep doing it. They still would use the standard Java plugin. I'm not going to try and replace it or anything like that. I will react to it. So there's a lot of code in Nebula that uses the plugins.withType. And so we look for certain plugins to come online. So once the users apply those plugins, we can then do what we think is special to Nebula. I thought I'd throw an example here in of how we do an extension. Nebula is an aggregation of many plugins internally, and all those plugins have their own extensions. And if those developers had to configure all those plugins, a lot of stuff to understand. File gets sort of long. Here's my find bugs section. Here's my Kobatura section. It gets a little bit long. So what Nebula does is one has super specific thing to us. Like we would never push out a ready for Java 7 flag to anyone else. But what we'll also throw in here is using some @delegates on our extension, references to other plugins, so that they don't know behind the scenes is a plugin. But if they want to, we'll tell them. But that's why some of the stuff gets to stay simple. And then you start adding dependencies as usual. So this is the way I would like the build to look, and usually it does stay this way. If I go to a team and it looks like this, thumbs up, I can help them. I can help them right off the bat. There's nothing too special going on. Predating all of our Gradle work, for the internal bit of the company was Netflix OSS. If you're not familiar, Netflix releases a lot of open source projects, some better known than others. They're really impressive pieces of software. I highly recommend you go check them out. When they were starting to come out, we didn't have a Gradle build yet, and they were starting to say, let's do Maven. And I'm facing a world of a public build that's all Maven, an internal build that's Ivy, and making them all happy. So I tried to use the opportunity to make a Gradle build for the open source projects. And it was still a bit of a rush, right? Once they start going out with Maven and stuff, they're not going to want to replace it. So we sort of did a rush job on getting a Gradle build out for the OSS projects. So if you've interacted with them, I'm really sorry, because it was a fast job. I did it a while ago. There was also value in the way I did it. It's a very transparent way of doing Gradle. We showed how we applied every plugin. We set all the configuration there. Nothing's hidden in some special Nebula Netflix OSS plugin, which is really what I was trying to do. I didn't want people thinking, because Gradle was new to people at the time, I didn't want them coming into Netflix OSS saying, hey, where's my POM? Oh, we use Gradle. What's Gradle? It's this thing. Where do I get the docs for this custom thing? Now they're just confused. I want to say, no, this is pure stock Gradle. There's nothing special going on here. So I think it's been a learning exercise for people consuming our projects and looking at them, and it gets us by, but it's just not going to last forever, right? It's still in 1.6, for example, and we just can't sort of use that ourselves. So for us to keep things manageable, our goal is to unite those two builds, have what we were doing on the internal build be used on the external build. We've done a lot on the internal build since the external build was done, and we want to leverage that. And so as we were looking at how can we reuse this code and stuff, the obvious answer was plugins. At the same time, we were faced with an internal plugin that was pretty monolithic. It was big. It was just a huge mess of code, very few tests. So we took the opportunity to split up the internal monolithic plugin, break it up into smaller plugins for use on the external Netflix OSS. And those are the plugins that I'm going to be talking about today. When we started looking at plugins, which maybe many of you might have done so far, I was quite surprised how few of them had a release process. It's sort of ironic given the space that we're in, okay? Like, seeing that like this thing gets published to someone's GitHub repo, like would I ever do that internally in my company? No, I get fired. Not have CI, reproducible builds, it was just ridiculous. Like I wanted to try and see what I could do to correct that. And I get it's just time consuming. Like I've done side projects, I'm not gonna put too much, I'm on the couch on Friday night working on this stuff. I'm not gonna put too much time into CI builds and stuff. But this is part of my job. So we made Nebula plugins. Nebula plugins means many things. In one respect, it means infrastructure. What we have is a GitHub repo that contains all of our plugins. It means that we have CloudBees running them, so CloudBees being the hosted Jenkins. It also means that we use Bintray for publishing versus going through Sonatype, which we do for Netflix OSS, but the automation wasn't there. And the key bit here was automation, automation, automation. I really wanted there to be a public button that some people, given the right authorization, could click release and get these plugins out there. And it didn't have to be us. That is sort of the goal we're trying to go with these plugins. Likewise, a mailing list, somewhere to contact, right? Don't necessarily file a bug to ask a question. So there is a mailing list associated with it. And hopefully, if any one project gets big enough, we would spawn out other mailing lists. I've worked on enough open source projects that if the project gets big enough and there's enough activity, it absolutely needs its own mailing list. Consequently, we also have a plugin that helps us keep the plugins we're writing very similar and have certain rules for them. So when you go up to GitHub, you can go to the nebula I guess the URL didn't make it in here, sorry about that. It is nebula-plugins, and you will see all of our repos. I think there must be about 17 of them. If you want to see an example of what these plugins look like, I send you to the Gradle nothing plugin. It just does nothing. But that sort of means it won't distract you from all the other stuff that we might be trying to do. We tried to write these as clean as possible. We're happy to get code reviews, right? If all you're going to do is go look at these and say, hey, this is sort of, the docs are bad, or this is crummy, tell us, and maybe we can work on that. We're really happy about that. It also serves as a corpus of examples that might not exist anywhere else. There's a lot of plugins that have been written back before extensions were being used that you shouldn't do anymore. We're going to try and keep this stuff update and modern. One thing we noticed is that there was some admin overhead to this, and we experienced it on Netflix OSS. We experienced it in Nebula plugins. We said that's 2's enough. Let's start automating this. So there's a project called Ensure, and that he's there to ensure that every repository has a description. Make sure every repository has the webhooks that we want for these projects and stuff. Really try and take out that manual process stuff. I mention it because you might want to use it. This is what I talk about today is also to see what we can get for reuse out of this stuff. We'll be using the same sort of logic on Netflix OSS shortly, so hopefully we'll be reusable in a short time. It makes sure that there's a contrib team for every repository, and to make sure that every repo is in one team called contrib. These are just sort of patterns we've seen on GitHub orgs that we sort of liked, and if we could script it, we do. So that takes care of some of that GitHub aspects of it. On the continuous integration side, actually, give me a second. So I was reminded that I'm highly incentivized to end early today, given that's the end of the day and there's beers and dinner afterwards. But there's still a lot of material to get in here. Continuous integration. So I want the same jobs for every repo. There's a way to do it called the job DSL. I've heard a bunch of references this year to it, which is great, even though this isn't the Jenkins conference, it's the Gradle conference, but it seems to still come up. It is all checked in. You can see what we've done. So if you're looking for examples of the job DSL, this can serve as a pretty good example. What we're going to do is create a snapshot job, a release job, and a lock job, and a pull request job. Okay, these are all relevant jobs for open source projects. The other thing would be per branch. As I mentioned earlier, we're happy to go to the internals of Gradle to make what we're trying work. It means we break across versions, and we've had that before. So an example would be the ospackage plugin. Did some internal stuff with copy specs that has changed in 1.6 and 1.8 and 1.9 and 1.10. So we create branches for all these things, and we do release off each of these branches. So one of the practices we've seen, or we start to implement ourselves, is every one of these projects, when it releases, the major minor is the Gradle major minor. So when you see a version of 1.12.0, that is meant for Gradle 1.12. There's a lot of portability across plugins. I'm not going to say that's like a requirement, but we're going to start doing that. We theorized not doing that, but then we found ourselves still having to keep some sort of major number up to date, and this one had the most relevancy. It means I can always ask for my version of Gradle .plus, and I'm going to get the latest and greatest. So this is something we're trying out. This is sort of what you'll see across the branches, right? So you're seeing a release branch for the 1.11 branch, one for a snapshot from 1.11 to 1.12, 1.9, so on and so forth. For Netflix OSS, the release job is internal because there's all these credentials and stuff. I found a way in CloudBees to hide the credentials in a relatively safe manner so that we could put the release jobs up here and not give away too many secrets. I mentioned job DSL. I'm a fan. I'm also the creator of it. But I'm not going to show you how we can sort of make a pretty straightforward REST call, loop through all the repos, and do what we want to do for each of the repos. We really like this pattern and stuff. I also recommend questions anywhere along the way. I'm perfectly happy to answer them. Getting those binaries up and out, I can't tell you how many people say, hey, I published an Nexus. Why I don't have it? Oh, you forgot to close I don't remember what they call it anymore. Close it and then release it. Where is it? It's not there yet. You got to wait 4 hours, all this stuff. Going to bin tray meant, one, we had the APIs to publish it and close it, and they show up right away. That's been a huge win, was the API so far. So we've been a big fan of using bin tray and stuff. Some holes in the API that we're trying to fix and work on. The other thing we try and do with bin tray is make sure that all the packages look good. So for instance, that we set the license, we make sure that the description includes the GitHub references, stuff like that. It can be a little tedious trying to keep those all up to date across 20, 30 repos in GitHub and stuff. But you're probably most interested in the plugins. Pretty much we found every time we wrote a plugin, we're writing a plugin because it's a really good idea for a project to use, which of course means we should be using it ourselves, which means we got into almost this like really hard bootstrapping thing where the plugin needs these plugins and those plugins need the plugin. Okay, so bootstrapping this thing was not easy. I will tell you that right now. But this is the general set of plugins we try and use for our plugins. I'm going to walk through them, so I don't really need to explain, but there's a general dependency graph that you guys can sort of recognize. The distinction I sort of want to make while this is up is some are prefixed with Nebula, some are prefixed with Gradle. And the only reasoning here is trying to give some indication of when we're trying to be very opinionated and when we think this is generic for anybody. Okay, for instance, we have a Gradle contacts plugin. This just lets you declare these are the people involved in the project. That's pretty generic. There's nothing to do with Netflix or nebula-plugin-plugins or anything like that. So that gets a Gradle prefix on it. Something like the project plugin. That's one where we sort of have these opinions about your project. By definition, that project is opinionated. So we put Nebula in front of it. Relatively arbitrary. It also means if we feel like we haven't given enough flexibility to the user, we'll put Nebula in front of it and say, oh, that's just our opinions, and we're just being opinionated. But if you truly think you have a really good generic plugin, we are happy to just prefix it with Gradle. I think it's pretty safe in the community to prefix with Gradle and end with plugin. This is sort of what they do a little bit in the Jenkins community and stuff. It's a nice pattern. I think it's a little weird when I find a project that doesn't have the word Gradle or plugin in it, but it's a Gradle plugin. Nebula test. So I'm going to work through these plugins / jars. I think they're relevant to pretty much everyone here. So if they're not, tell me. If they are, and you're thinking of using it, tell me, and I can help you try, with adoption of it. Nebula test. So testing plugins, there is nothing to be said about it. There's so little docs on how to do it. You go to the internal Gradle code, fantastic test suites to use and stuff. We wanted the same thing. We started using the Gradle launcher. Now, Gradle launcher has been deprecated since like day one, since I've used it, but it's still around, so we liked it. This thing has since evolved. So now we have a thing called the project spec. This is a Spec specification to run the project builder. The project builder is just an in-memory way of making a Gradle project. It doesn't evaluate the project, it doesn't run tasks for you, it just lets you apply some plugins and then look at the state of the world. The little secret is you actually could run evaluate, which is sort of nice. Many of my plugins do require evaluate, and so I can do that. That's the fast one. That's the one I recommend you using if you can. The fallback one is the integration spec. Actually, let me mention the plugin project spec. Since we're writing plugins, there's some things you always want to do for a plugin. I want to make sure my plugin can be applied. Can my plugin be applied twice? Can my plugin be applied across multiple projects without dying? So if you use the plugin project spec, we'll do all those tests for you. And that's just a basic sanity check. Can my plugin be applied? That's its use. Pretty thin wrapper. Integration spec. This is essentially saying we want to run Gradle. Running Gradle is going to be a little slow, but it's worth it because we can actually run tasks and check the output. For instance, we use the ospackage plugin. He's making Debians. Like, we need to see if it made that Debian, and we need to pull that Debian apart and make sure those files are there. And that's where the integration spec comes. There's two modes. There's the Gradle launcher, which is the older deprecated mode. It is not the default, but is the only one that lets you set debug points. Okay, this is sort of a nice thing. If you're working on a plugin, I could debug it. The other thing is, when it's done running, you can get a Gradle object back, like the Gradle object. And you can say, give me all the projects. You can say what plugins are applied. It's a great way of inspecting the state of the project after everything was run. It will be removed from Gradle eventually. I probably shouldn't even mention that I'm using it. I've now incentivized Gradleware guys to remove it. The fallback is the tooling API version. I took some of the code suggested by Luke called the Gradle test kit, I think it was what he was calling it. But it didn't have a release process, right? This is the problem we were talking about with plugins that don't have a release process. They're not out there. They're not in Maven Central. They're not on JCenter. So took his test kit. I took some of the project spec stuff from Marcin's work on some of the JavaScript projects, merged them all together, and that's what we get. So I like to think that this is sort of the best available way of testing plugins out there. Not to say there isn't better. The stuff in Gradle is better, but this works really well. There's a lot of things to help you set up your project. This just gives you an example of how you would want to test your plugin using the project spec. Classic Spec, when, then, essentially apply my plugin, see if a task exists. In my case, I'm actually going to run the task and check the output. This is also another case where there's a project dir variable available too. So these are things that, these things are going to run in unique directories. So if there's output, you can isolate that output. It's not going to get polluted from multiple tests running at the same time. Some of the patterns we found that we like. The integration spec, like I said, we're running a real Gradle build. Real Gradle builds need build.gradle files, setting.gradle build files. Now, there are some default setting.gradle that will set like the project name for you correctly. This is an example where I'm going to sort of spit out what I want my build file to look like. There is some utility methods to set up a Gradle project. So write hello world. Sometimes I just want to make sure the compiler runs. And so this little hello world function just writes out a JavaScript. It's a Java program class, sorry, that can get compiled. We also then have these sort of post-run. So after you've run, you can sort of check the state of the project, right? Does a file exist? That kind of stuff. The big call you make is run tasks successfully or run tasks with failure. Essentially, it runs it, does a real build, comes back with the result, and you can check the result and see what tasks were run, were they up to date, stuff like that. Really works you through the life cycle of your plugin. I should mention Nebula Test was not an actual plugin. Neither is nebula-core. Nebula-core has evolved. It's pretty much tweened down to not much. It's just some utility tasks that we haven't seen anywhere else that we wanted available. So just a download and untar and unzip. There's an alternative archive task. So if you're not familiar that there's actually an abstract archive task that you sort of need to use in Gradle, but it extends a copy task. I don't always want to be a copy task. And there's no interface for it. And so there's an interface, but there's no implementation. This is an implementation of it. That's the kind of stuff we're trying to throw into nebula-core. Stuff that you maybe could have been, should have been in Gradle, or at least we use it often enough that we want it in this module. This is also a good place for helpers. So with the ospackage stuff, we did a lot of work with copy specs, and I didn't really understand them, and I found that it was a little hard to work with them and dig into them. So there's some methods that we have available. I guess I can sort of show you, like visit a copy spec. We can do a dry run of a copy spec, like run through it. Tell me what you want to output. And I get a little closure, I get called on each one. It's been pretty useful to run through and make sure my copy specs are working. Sometimes I'll combine them and add them, and I want to make sure they look right. On a similar helper sense is class helper. This is just Java stuff. This has nothing to do with Gradle, but we used it enough. We in Netflix shove a lot of metadata into our manifests, into the jar file. And this is some utility methods to just grab the manifest, grab some properties out of it and stuff. You probably won't be seeing that too much. This is an actual real plugin. Okay, so finally we get to a real plugin here. This is probably the most useful one and has the worst docs. So sorry about that. Okay, I will come back and try and fix the docs. It was either write the docs or give you slides. So I think we'll all go with slides on this one. There's two asks to it, and that would be archiving, so making archives. I don't know how many projects I've seen that make their own Javadoc jar and their own sources jar, and sometimes a test jar. That's less common, but these are crazy common in Gradle projects. Like if you search for GitHub and you look for those lines to make a Javadoc, we've all copy and pasted it. So I thought I'd throw it into a plugin, and that's what this is. There's just a plugin that says, give me a Javadoc, give me a sources, give me a test jar. The other aspect of this plugin would be how you publish. Hopefully you haven't had to know the ins and outs of the publishing 2.0 stuff. So somewhere around, I don't know, 1.8, 1.9, they came out with some new publishing code. Never really got done. I think by all accounts, everyone agrees that it just didn't get finished. That's fine. It had some features in it that we really wanted, so we adopted it, and it was great, and then we found the parts that weren't done yet. And we were pretty far down the road, but we really wanted it, so we made it work. And to make it work, we had to make our own custom component, right? This is one of the objects component. There's a Java component, a web component. There is a custom component that we have that we use that works friendly with all the internal stuff. It just isn't one of the Gradle classes. The publishing plugins you see here work with those to let you publish, I don't know, a relatively more rich fashion. We're publishing to IB files. We want a little bit more control on what confs are getting created, what dependencies go in what confs, how it gets displayed. And that's what was valuable to us. I think for Maven, it won't be as valuable. What would be valuable would be these two resolved plugins. If you're not familiar with, you can have dynamic versions in Gradle, right? I can say 1.plus, I can say latest.release. Those are great. You pick a version. You then take that version and go smack right into the POM file. Not exactly what you want. Typically, you want to put the resolved version, right? If I'm asking for 1.plus, I really want 1.1 to go into my eventual POM file, right? You're a pretty bad Maven Central citizen if you're putting dynamic versions. I will probably hunt you down at some point if I find you publish in Maven Central dynamic versions. It is very annoying. But that's not in sort of stock Gradle, so we wrote a plugin to just resolve those numbers for you. If you use the dynamic version, we're going to replace it with the static version. I think this has a lot of common use case. The other thing would be excludes. If you have an exclude in your Gradle and you want it in your POM, these plugins also do that for you. Okay. What we're lucky is that the Gradle APIs give that to us, that let us add this on later. And we write the plugin, we use it, we're happy. But I'm also here just trying to tell you guys so you guys can be happy too and do the same thing. It's not always clear what's going to go into Gradle, right? It's meant to be this toolkit that serves so many different customers. And maybe us Java people publishing Maven Central aren't the primary source or target audience. This makes us happy. These things here will give you a project that would look good on Maven Central. I mean, I think if you try doing this syncing from bin tray, it's going to complain. You don't have Javadoc, you don't have sources, you haven't signed it, you haven't done all these things. These plugins will do all those for you. Okay, you will get a relatively responsible build using these. The last one would be nebula-sign, who's mostly responsible for just the signing. There's a lot of code out there. It's about this long to sign it. It's now apply plugin nebula-sign, and it's one line. And we just document, here are the properties you use to control it. If you don't have those properties, we fall back nice and safe and we don't blow up. So an example of it would be here. This is me sort of applying those plugins we just talked about. The one at the top is sort of an Uber one that applies some other Maven-y stuff and does the resolved Maven plugin. And you get all these files, right? This is a lot of files, and you see the signing and the jars and the hashes for them and stuff. This, to me, now that looks like good output. That's what I want to see in my little M2 repo when I'm looking at it and stuff. Moving on to the next plugin. We call this the Gradle info plugin. Right? We found internal to Netflix, the things we were doing in our Ant build and CBF was gathering all this info, right? Info like, what version of Java are you running? What are you targeting? Things from CI stuff. So what Jenkins server are you on? What's the name of your job build? These are just stuff that we store with every build, and we put it into the IB file, and we put it into the manifest of the jar, and that's what gets published. This means if I ever see a jar, I can open it up, look at it, and I know exactly where it came from. I know the build number, who did it, what time, the hash from source control, what repo it came from. I want this all the time. I find it's a little frustrating finding a module in Maven Central bin tray and finding out that I don't even know what hash it was built at. I can't go back to that release. If they didn't tag it, I cannot reproduce that build. It's a little irresponsible as far as I'm concerned. So this plugin is here to collect that data. So there's a middle broker, and these plugins at the top provide stuff. So if it finds stuff from source control, it reports it. If it finds stuff from CI, it reports it. If it finds stuff about Java, it reports it. The broker can take input from anyone. So if you have your own custom things that you want to store, throw it into the broker. Then there's the output side. We can throw these things into the manifest. We can throw it into a properties file. We can put the properties file in the jar. I mean, there's all sorts of places to put these things. You can make an artifact that gets published with it. You could publish to some sort of database if you want to keep track of all this stuff. What you do with it for the output, not as important, but I think super useful. So these are the ones that come out of the box, giving you a property file and putting it in the manifest. The property file is nice. Like if you're in Jenkins, you can archive it. You can pass it from job to job to job and maybe affect your downstream jobs using it and stuff. It looks like this. I thought I'd throw in the whole thing here, start to show you what you would have to do to consume these plugins. We default to JCenter. In our case, the info plugin by itself is fine, but we want to throw in here JGit. So this is sort of reacting to, if you have JGit, then we'll look for a Git repo and we can report on it. Some ugliness, I'd love to clean this up a little bit somehow. Apply plugin info. That's the Uber one that applies all the other plugins for you. It won't hurt anybody to get a few extra fields in your manifest. It won't hurt anybody to have an extra property file in your jar. So it's very safe to do. And what it looks like is something like this. This is all the stuff that you get. I think if I was doing it manually,
what does that do to up-to-date checks?
We deal with that. So there is, we do the inputs and outputs. What we do is we tag the fields. When you're adding stuff to the broker, you tag it and say, this is time-based. Feel free to ignore it. They're mutable. When you do it, you say that this is mutable. It's going to change over time. Don't worry about it. Every other one gets calculated as part of the inputs. And so it does become incremental. So that's good. If it doesn't work, we should fix it. I think there's everything that we need in Gradle to do it. One of the problems we do face is that the outputs of tasks are limited to files. We don't always write to a file. Sometimes we're just writing to a map in memory, or it's going to go into the jar. And so I have to sort of say that the output of my calculating is in a jar. So it gets a little weird, but the plugins take care of it for you and stuff. I think if I was manually doing it, I'd probably do like half of these. So I might not need these until I need them. That's sort of the classic example, right? Something went out to production, you're sitting, your war is exploding, you're like, where did this come from? You want these things there. And this is easy enough to apply. Next plugin, contacts. You see it on public Maven projects. There's a developer section, right? So it's some way of saying, hey, I'm involved in this project. We had an equivalent internal to Netflix called module owners and module email. And they serve different purposes. Module owner would be, who do I email if I have questions? Module email, oddly enough, is who do I email when this module is released? Those are internal use case that I was trying to map and whatnot. So we abstracted out and made a little DSL for just describing who's involved in this project. And we then, this is an example of how we feel that some plugins can talk to other plugins without using a DSL. And I don't know how much that makes sense. I'm happy to have either the user or another plugin just reach right into my plugin and start asking me questions. Okay? It doesn't, the contract between plugins does not have to be a bunch of files always. This is an example where other plugins can come in and ask me questions. So, for instance, the Contacts POM plugin goes to the Contacts plugin and says, hey, do you have anyone that is marked as a developer? And for all the developers, they're going to get put into the POM. And the way it sort of looks is something like this, where you can define roles. So by default, you see along the top, contacts, Minnie and Mickey, they're involved. Hey, they're involved. I've grabbed their email. That means that anyone who asks for who's involved or has asked for a certain role, they're going to get Mickey and Minnie. Or you can take the more rich DSL and start to fill in what their roles are on the project. And then you could do different operations on it. So if on a release, some team wants to know about it. So here you see downstream at netflix.com, role notify. And those people get notified. The other thing that you can get in this DSL is you can say what their full name is, all the stuff you see in the developer section of POM. So you can give me your GitHub ID or your Twitter handle or any other miscellaneous stuff or like a full name. Not as relevant for this discussion, but it's in there and stuff. I like the concise syntax, right? I can just say contacts. Like if you want to contact someone, here who's the contact. I think it reads sort of nicely. Because you got to remember too, we're not coming from Maven land where the POM is sort of your project description and it's your output and it's the whole thing. I can go to POM, if I want it in my output, it has to be on my input for the most part, right? So that's where the developers are. So this is sort of carrying that same idea through. Next plugin. This one's sort of light, but I just want to bring up the topic of plugins to help other plugins. We're working on a release plugin. He needs SEM. You can't get away from it. The info plugin, he needs SEM. There's a few times that we all need SEM, and at Netflix we have a mix of Perforce and Git. So one, we need the SEM abstracted out, and multiple plugins need it. So what we're trying to do is develop plugins to be used by other plugins. So there's nothing you can really do with this by itself, but if you do apply this plugin, it can provide information to other plugins, and those plugins react to it. So like the info plugin says, if I see the SEM plugin, that means I now have a thing to go to and ask for SEM info kind of stuff. So it's a little reactive in that sense. I like the model. I think it's something we could start talking about as sort of a community. I'm alluding to the dependency-lock plugin, just like Hans referred to in the morning. So who's used bundler before? A few hands. And there's actually a few equivalents of this. The basic idea, let me conceptually explain it to you, is you've asked for a dynamic version, and every time you run, you potentially get something new, right? We've all seen this where someone published something new to the repo, and all the developers' builds are broken. Whole company down, right? That sucks, okay? That's happened at my previous companies and stuff. The alternative is to just use static version numbers, right? Manually go in there and put in a field of 1.11 or something like that. But then they get out of date and they get stale. So they both have bad sides to it. So we're running with the concept that Bundler has and that we have with our internal builds to lock it down. That's the terminology we call it, is locking it down. We're going to let the developer ask for their ideal situation. Okay, don't get into the nuances of what is out there today or what will I not get burned with. Just ask what you want for. I want the latest release. That's really what you want. What we'll then do is we'll do a build and try out what you've asked for, this ideal situation. And if it works, right, you ran your tests look good, we save a file. And this file can get committed into source control, and then it's there. And it's there for everyone else, right? This now is a file that stores dependencies that are known to work for everybody. It looks something like this. Apply plugin Gradle dependency lock, you run generate lock, maybe throw a test task in there. It outputs a file. This is all JSON. It's relatively easy to read. We have a real utility for having it easy to read and write. I guess I'll explain that in a second. But you can see here, let's see, did I figure this out? Yes. Here's an example where someone was asking for the project plugin. I want 1.12.plus. He went out and found it, and he found 1.12.0. That is now locked, and it's saved. And next time you run your build, it is going to use this file, use the resolution strategy that's available in Gradle, and set the version to 1.12.0. Okay? It's going to be a little confusing, right? You're going to look at your Gradle file, you're going to see 1.12.plus, and then you're going to do a build or your IDE and you refresh, and you don't get the newest thing out there. You don't have the newest thing because it's locked down, and that's a good thing, right? This is purposeful. You can skip the processing of it, right? This isn't like an end-all be-all, but it means that you have a real stable build, right? If I check this out, I'm going to get the dependencies, at that point. Question?
How do you then discover that one of these dependencies, what exactly is breaking?
When you run, the general recommended practice is that teams would run the generate, lock, and test every day at 5 a.m. or twice a day or whenever, however you want. That build is the only build that's looking for new dependencies, that build will break eventually. And someone gets an email from Jenkins saying, hey, this build is broken. Why it's broken? Can't say. Not much I can do about it. Yeah, we're not going to get into the magic areas of what could break. No, but we could get into like, well, let's lock down these 4, but not this 4. Okay, you know, sort of do like a bisect kind of thing on Git, you know, to see what broke or something. We could do that. That's completely available. When we're processing this file, it's just a file. It's just JSON. You know, modifying this file is easy. So we would probably do something like a bisect. Like we could discover it. I find though, most teams are sort of like, I'll just wait till tomorrow. Maybe it's better by then. Because right, if those developers come in that morning, that build broke, they come in the morning, they update, they sync, whatever, you know, depending on their source control. The dependency log file never changed, right? No one ever checked in a new file. They still have the old dependencies from yesterday, and they're still working. So it isolates who has to care about how it's broken, right? So the person who got the email from Jenkins has to care about it. The rest of the team does not. I'd say the alternative day-to-day practices of not doing this is either breaking all the time, which doesn't really work, or you lock it down and you get so out of date that when you do get up to date, everything's broken. So this is sort of more of an agile, iterate often kind of solution. It also applies to the latest .release. It really doesn't matter what it is. I think in the future, if we start getting better, different kinds of ranges, it doesn't matter. We're just asking Gradle, what did you choose? Right? This is there's no internal stuff we had to do for this. This is all easily available in the public API and stuff. I'd say if you leave this talk and have to use any plugin, this is the plugin you walk away with. This is hugely valuable for your teams and stuff. The next plug, Intitext. Just sort of, this is another example where if you look at enough Gradle projects out there online, right? Not just plugins, but Gradle projects, they set up an integ test, right? They make the source set, they make the configuration. We've seen it 100 times. It's copy and pasted, and we're really trying to cut down on the copy and pasting. So there's a plugin that does what you would think it would do. Makes the task, does all the stuff that is documented that you should do to make integ tests. Maybe someday we'll expand this to be any set of tests and give it a DSL or something like that. But right off the bat, nice, easy, quick way to get some integration tests as a separate source set, separate configuration, the works. The nebula-project-plugin. Okay, so now this is where we're starting to take those plugins and pull them all together and apply them to the project. And the idea here is we want these projects to do what we expect a responsible project to do. And if they don't think it's a responsible thing to do, sorry, they have to do it. This is like, you're not being a good project if you otherwise, right? If you're a Java project, you should make Java doc. Sorry, like I feel pretty strongly about that. And that's what this thing is doing for you and stuff. It just pulls them together. It applies all the plugins we saw before. And I think it is one other thing, like if JavaDoc fails, it doesn't fail your build. Or let's see, what was the other one? Oh, the Java plugin. It's a little side note here for anyone who knows. When you apply the Java plugin, whatever status you set at that point gets completely wiped away. So the one that this thing does is whenever it sees the Java plugin be applied, it sort of saves the status, lets the Java plugin run, and then reapplies your status. This is one of those things where we use status heavily because it's an Ivy, more of an Ivy concept than we use Ivy. It was important for us. So this is kind of us just trying to protect ourselves. But a plugin acts a little bit different, right? So a plugin, now we're starting to get into the zone where we have to be pretty opinionated about plugins. In our case, nebula plugins, we want them to have a certain release process. We want them to be published at a certain location, stuff like that. And that's what this plugin does. It does sort of have some bin code that we probably should have pulled out to another plugin, but we haven't. But in the end, this is the plugin we use for our plugins. It turned out to be really useful for the plugin portal, right? I guess we can talk about the plugin portal now. So we got the sort of note saying, hey, if you want to be in the plugin portal, you have to add these fields. Okay, it looks like a lot of manual work. We got like, maybe 10 different repos and stuff. But we looked through what actually had to be done. We said, well, we already know all this. We know what plugins are in these projects. We know where we're publishing to. We go into bin tray. We can set the attributes. We have everything we need. A valiant effort by Rob Spieldenner over here. He added to the plugin to add those fields for the plugin portal. We re-released all our plugins, and now they're in the portal. Okay, we did not go to bin tray and do anything special to make these things in the plugin portal because we could leverage this plugin. this idea of a plugin or any sort of aggregating plugin, I think is really valuable. You're going to see us do this for Netflix OSS, right? There's going to be apply plugin Netflix OSS. It's going to do all the things that we want for our Netflix OSS projects. We're going to be breaking out, RX Java is going to live somewhere else soon. Well, we're going to make a plugin just for the RX, for that set of rules, how they want their org to work and stuff. So I think we're going to find this more of a pattern, right? These really thin plugins that just put a bunch of conventions down and opinions to make everything consistent experience for people. So now I'm starting to jump out of those core plugins that we use. This one's called the ospackage plugin. Okay, we looked at a few plugins. Initially, we were trying to build RPMs on our transition from an Ivy to Gradle. We need to make RPMs. We could call RPM, right? We could make an RPM. We could have them specify the standard. God, I don't remember what the file is called anymore, which is a good thing. Thank you. Yes, Spec. So we looked around, and I found one that sort of could put it together. But then there's this other plugin called the Ubuntu Packager plugin. We didn't really care about Ubuntu at the time, but it had this really neat feature of taking copy specs and defining what you wanted into it using copy specs. So we sort of just merged them all together to one plugin. So there's one plugin now called the ospackage plugin. Use standard Gradle copy specs. This is where you go from this directory into this directory. So you've seen it plenty of times. And it will make Debians and RPMs. It uses JDeb and what was the other one? Redline, thank you. It does use Redline, which means it's purely Java. So up to this point, most of our developers had Windows and Mac laptops. They couldn't build RPMs locally. They couldn't even test if it had worked. So now, pure Java solution, and they can build their RPMs in Debians. I just thought it was an interesting exercise in the better thing, right? People had access to RPM spec files. When we showed them this, they're like, oh, that's a little bit different. Wow, really? That's all I have to write? Because we could set all sorts of stuff, right? We could set all the sorts of, what distribution is it targeting, right? Netflix, we only have one distro we have to target necessarily. So we can lock down all these fields, pre-configured for them, and give it down to a one-liner. And if they say they're a web project, we'll just put the war in the right location and they're done. No lines, done. Apply our plugin and you're done. So that's sort of a big win. This is sort of an example. I mean, it's very specific if you're making a system package, which might not apply to too many people. But it was just a big win for us. And actually, some of our Python developers, some of our system developers who are writing packages for our Ubuntu systems, instead of learning control files, they found this easier to use. They now actually use Gradle to make all the Ubuntu packages for our base AMI at Netflix because it's easier than Debian control files. Right? We've essentially gone from Java right to the system package, skipping that little middle thing in the middle. The override plugin. I'm just trying this out. I don't have this plugin yet. Okay, I could say I do, but if you go look, it's not going to really exist. There's this use case that we did in Ant all the time, right? There's some property that drives the logic. They would have a Jenkins build, and they just put a little -d, and they'd set a property, and the whole behavior of the build changed, right? Did this all the time. We find this a lot harder in Gradle. If, let's say, find bugs is failing, but I need to get a release out. Well, what you have to do right now is edit your build file, check that in, do another build and see if it works or not. That doesn't really work well for us. We'd really rather not change the build file just to get past some problem or change some minor behavior. And I know that there are project plugins, but project plugins is sort of its own DSL, right? This is your way of saying, I'm going to make a magical property that's documented somewhere that's going to change behavior somewhere else. And we don't want to make, for every possible knob in Gradle, some corresponding project property, okay? So the goal here, and this is where I'd love to get some help on, is to be able to specify something like -n, nebula, findbugs.enabled equals false. This is valid Groovy code. So what we're looking to do is just evaluate this as Groovy code and so that it can handle the nesting, right? Go into the extension, set something inside the extension. This is how I would maybe get past find bugs really quickly if I had to and stuff. Gives us sort of the big features we had in Ant that we don't have in Gradle, but we should be able to do. I've been talking for a while about our external plugins. We have lots of internal stuff, right? This isn't all we had, but we're really making an effort to open source the stuff that we feel is really generic and stuff that we need for the Netflix OSS. So it's a little selfish. But I thought it'd be interesting since we're sort of talking about how we do Gradle internally and maybe what you guys can do too. A common pattern for us is wrapping other plugins and then configuring them. So an example would be find bugs, right? We'll have a Nebula find bugs plugin. He's going to apply the find bugs plugin and then set the version of find bugs so that we're all on the same page. Or pick the one that's in our repo. Stuff like that. That's a common pattern for us. So our Gradle code internally is getting smaller and smaller and smaller, which is our real goal here. But it's also, whenever someone comes to me and says, I need to do this weird little thing, I make them a plugin and they can apply it, right? I'm happy to pump out plugins all the time for people because it's up to them to apply it. If they don't apply it, no one else gets the behavior. So it's been a good pattern. People come to us, they want something, yep, here you go, done, get off, get away, shoo. I got other stuff to do, and I can make them a plugin and stuff. And so that's sort of reinforcement that the Gradle model works well for us. This is what a plugin, if you're going to write a plugin using the Nebula plugin stuff, this is what it sort of look like. I mention this because I actually recommend you. So part of the point of Nebula plugins is to encourage other people to move their plugins to this repo and all this infrastructure, right? This is not meant to be the Netflix plugins repo. This is meant to be, how about the community? If you don't have a public Jenkins setup, or a good GitHub repo to use, or somewhere to publish to, and you want to get to Maven Central, you know the credentials or all that stuff, we're inviting you to come into Nebula plugins, okay? And I'm going to show you in a moment just how to get started and stuff. But I don't know how interesting this will be. We're going to see. I know going forward, if I come across a plugin that hasn't been released in 2 years and it's out of date, I'm going to see if they want to come and join the repo and get all that CI stuff with it and see what kind of good patterns we come out of it. Maybe we take all the code I wrote and we just replicate it for other orgs. Maybe you have your own org. That's fine. Maybe we could see what we could do with that. These are the steps for making a plugin. Like, this is everything, okay, to making a plugin. And I'm going to sort of maybe jump into that. I think I got plenty of time. If along the way I'm waiting for something to build, feel free to ask a question so I don't look as awkward up here. Let's see. Anyone have a plugin they want to make? No. So we use Lazybones to give ourselves some templates to get started with. So there's a Nebula plugin template for you to use. And that's what we'd recommend. I already have it installed, so I'm going to skip that step right off the bat here. Hub, Nebula. This is sort of our syntax. I'm going to run lazy bones. Sorry, I don't have my screen mirrored. This is going to be interesting. Create Nebula plugin. Let's see. Someone today asked me to break out the bin tray stuff we have in the plugin. So I'm going to make a Nebula bin tray plugin today. And it's okay. So Lazybones is great. It can ask you questions and to help you drive the templates and stuff. So I'm going to say additional bin tray tasks. I'm going to call it this. I'm going to give it that package. Give myself a default class. I'll put myself in here by default. I am Quater Ryan, and I think I usually use this email. Okay. If I was to look around here, or here, sorry, let me seed into Nebula bin tray, and I run tree. These are the files that we have. Sorry, mouse. Already created for us, and we're ready to go. I could do a build right now, clean test, and he'll go run his tests. Oh, actually, he will fail in a moment. He doesn't have any source control yet, and the source control plugin is not too happy without any source control. So that's a TBD. So let's see, git init. Let's do git remote add origin, git at one of the features we don't have is an ability for outside people to create the repos yet. And so let me just go off and do that really quickly. Move a tab over there. So does anyone think they're going to leave here and take a look at these plugins? see, I should be all logged in. Let's do a new repository. Call this nebula bin tray tasks create. Let's go back to here. We have a get remote origin. That looks good. We're going to go through and do a quick, we could do the build, but that takes a little bit of time, so we'll skip that. Git-a. One thing you have to do is the jar file is going to act a little bit weird. It's not going to get added by default. So let's just add that in there. Git commit -m initial template to push set upstream origin master. OK, cool. We're essentially done creating the plugin, right? And obviously you have to add the logic, but that's easy, right? Though I mean that is a very interesting conversation we can have, but I'm going to sort of skip that. I'm going to go back over to my browser, refresh this. That's all we need to do, and I can, depending on timing and how fast I speak, we'll already have a Jenkins build ready to go. I hit release, and this will be out there. So, but I'm going to poke it just to be sure that this is going to run. So remember I talked about the ensure. So the ensure is going to go through and ensure that not only GitHub set up, but so is Bintray. So we're not going to be able to do a publish or release until Bintray is happy to go. So let's come in here. Let's log in. And we'll build now. This is where we're going to stick with delays and stuff. So I will continue doing this in the background, but any other questions? So who tests their plugins? Good, good. How do you guys do it right now?
Integration.
Integration tests? Like as in you just like?
Run some example builds.
Oh, OK, yeah, we do plenty of that too. I can't test everything.
Luke's project.
What was that?
Luke's project.
OK.
Steve from Luke's.
OK. Well, and that's what we're trying to like prevent. So, like, no need to steal all that logic. Let's pull it all into one plugin. OK, so now we have all that. That means if we come back up to here, we called it bin tray. Oh, the seed job. So I mentioned the DSL. He also has to run to create the jobs. He runs every 5 minutes or so. So just sort of kick him in the tires. Keep this compelling. Let me, well, I'll just keep moving this along. So these are the other steps that we were talking about for doing the release and stuff. But after I run that in the C job, I'll hit the release button, and it will all be out there. And that's all it takes to get a plugin out there. I can't even think about going through all the previous steps I would have had to do to get it out to Maven Central beforehand. We were talking about plugins. There's a lot of talk about plugins at this conference and stuff. There's been enough talk about unopinionated plugins and opinionated plugins that I'm not going to go into too much. But I will just add some emphasis that it has come up plenty of times where I have made a plugin, and then the people who want to use it don't want to use it the way I made it, right? So I do highly recommend the idea of making a plugin that can create tasks or react to the task getting created. So the classic example in ospackage is if someone creates a Debian task, do these things, right? Link up this thing and do this kind of thing. And that's one of our base plugins. And then we'd have another plugin that's more opinionated that just goes and creates one Debian and one RPM and copies from a certain root directory. Not often are you going to be making 4 Debians out of a project. You're going to make 1. That's pretty common and stuff. So we're trying to carry the common case, but also allow someone to apply the base plugin, create their own tasks themselves. And it's been paying off in spades. So for instance, I thought no one would want more than 1 deb, and then the systems guys go, oh yeah, we want to make like 4. OK, then great, here you go. Good thing I already structured it like that and stuff. Sometimes we even go in other level for these plugins. never mind. I think this is the kind of stuff that I haven't really captured well on how to describe people how to write plugins. I think there's still some room for it. I probably need to read every Gradle book out there to really know if anything exists out there and stuff. But it's just an important lesson to learn. Gotchas. This is a good opportunity while I'm off my soapbox talking about some of the gotchas using Gradle, especially with plugins. You're going to see lots of these domain object sets or named domain object sets. Really great for building a DSL, but they can bite. This one bites me in a different way. So come into you want to configure this new thing and add it to the list. But this class does not do this. This thing adds it to the list, then configures it. So if during a configure block you're trying to add a name, well, you needed the name before you added it, and so that becomes a problem. So there are some proper uses of these things, but you might get caught by that, where it gets added to the set, it doesn't have a name yet, so it fails, or it gets added to the set with a certain equals or hash code. We learned that the other day, and then eventually later you configure it, and now it has a different hash code, and now you can no longer remove it from the set. So there's a gotcha there. I mentioned earlier about the tooling API. You can't debug through it, but that's why we use the Gradle launcher for now, so you could do debugging. I mentioned too about output. I really would love to see tasks, inputs and outputs get wired together. But I don't always want to go through files. And so that's one of the headaches I find. That sometimes to get the incremental compile work, you have to write out to a file, even if you're not going to use the file, but just so it can do the hashing on it and get that correct. After evaluate, I think this is not everyone agrees that you should use after evaluate. Okay, but I cannot do my job without after evaluate. It happens all the time. I give them after evaluate, best way to put it, you make an extension, you ask your user to configure it. Now, if I take that extension and I just set it aside and then I run a task in the execution phase, I can use that extension no problem. The user's done, right? We've gone through evaluation. But what happens for me is I want them to put something in the extension, like to create a task. So I can't look at it in a task. I have to create the task. So to wait for the user to have configured it, I have to after evaluate. So this happens a lot. If I want to run before tasks run, but I want to see input from the user, it has to be an after evaluate. One issue, I have so many after evaluates, actually ordering becomes an issue. So on the Gradle helper that you saw in nebula-core, there's a before after evaluates. And it does these little hacky things to become really, really early, so it's not too late after evaluation and stuff. We just ran into enough cases where the lazy evaluation wasn't good enough, and we really need to get in there. And it's like this long to make that work, and I hope you don't have to go through that. So that's what those utility methods are for. I'm going to go back to the browser. Let's see, you ran. Let's see. OK, good. You went through that. Bin tray release. Oh, no. OK, back to the slides. There's a few things we need to do for our infrastructure. Oh, question.
Great.
Please.
You were talking about that after evaluate.
Yeah.
And kind of validating user input.
Yes.
Configure or something. Do you have any good other than?
Yeah. It has to be after evaluate. What I find, especially when I'm using the named ones, you actually will get the event that they've added this new thing to the list before the configure block is called. And so you're trying to validate all these fields that they put on it, but they haven't set them yet. And so we have another class that's in here that switches the order. So you can have a name domain set, but switches the order so you get a configure block first and stuff. But no, really, after evaluate, you just need a little block that just goes through all the values after the fact and stuff for validation and stuff. Yeah, this is sort of the internals of the Nebula plugins. There's a few things missing still, but we're hoping to get there. On the participating side, we do hope that you leave here today using maybe some of the individual plugins, maybe get on the Go group, see when we come out for new plugins that you want to hear about, or you want to announce your own plugin, right? I know that you could go up to the Gradle forums and announce a new plugin, but I don't know if everyone reads every forum post. This is meant to be more of a posting kind of interactive experience. Maybe you move your plugin to Nebula plugins. Maybe you really just do not want to release them. Now, mind you, if we added 2 Nebula plugins, I'm not going to maintain your plugin. Okay, this is not where it's going. But we will help you with at least giving you pull request jobs and the release job and stuff. So at least it's a click of a button. Or maybe start just a new plugin, right? I mean, I think I might take that new Apple App Store, messaging, which is if you're just doing a demo sample plugin, it doesn't need to be in there. But if you're doing like a real plugin that you really think it could be useful to the community, let's propose it. Let's get it up there. I got no problems adding. Let's just see where it goes. Definitely a good use case. Okay, back to our job. What happened? Oh, the demo gods. No test reports. Yeah, no big deal. Who needs tests? But you can see at the end, we've already actually pushed up, called the publish and the sync to Maven Central. Actually, that we could not do, but that's not a big deal. But that means if I go up here to, let's see, bin tray. I go to Gradle, plugins. I think is this the repo? That's not ours. No, I don't want ours. No, that's not anybody's. No, actually, I want the Gradle plugins. How do I differentiate, Fred? Oh, hey, there you go. That works. So I don't want mine. I don't want that. Is there? How do I get the Gradle one? How did that make it to the top? You got to work on your sorting here and stuff. Here, let's see. I can go a different way. I know that I'm already linked. So here, go Gradle plugins. Here we are. Let's get rid of this. So these are all the plugins. Let's see if there is see if this worked. And that did not work. So yeah, I'm not going to claim credit for that one. Or the missing things in it. Oh yeah, so on the manual list, we have to actually request being linked and stuff. There's no API for that just yet and stuff. So it would definitely be in our plugins and stuff. But after requesting JCenter, let's see if Fred says yes. No, but that was it. We have a fully working plugin that has tests, that has an easy path to Maven Central and to the plugin portal and all that kind of stuff. And the attributes are all ready to go, right? So if you go to a specific version, you actually can see here, this is the new Gradle plugin portal syntax that you need, and it's all ready to go. So sort of in the theme to all the other talks today, I am done early. Like I said before, please engage with us. Talk to us about what are good plugins, what plugins you want out there, what you could, how you can help out and stuff. But that's it. Thank you very much. Oh, actually, and we'll take questions for a while. I'm happy to use the time for it.
Just curious, I assume you guys using this plugin for your internal development?
Yes.
How do you get your company agree you can go public?
To write our own plugins? No, to use our
source those stuff.
Netflix feels pretty strongly about open sourcing when we can. It serves a few purposes. I mean, there's the hiring aspect, but it's just tech brands, right? So when we're looking to hire people, if they said, oh, we've heard of Netflix, we've heard all the stuff that you've done. If everything we did was secrets, no one would know what we did, and we wouldn't get all the street cred that we have.
There were no political big battles.
When the first Netflix OS project went out, the primary developer said, hey, I'd like to open source something. Is that okay? They said yes. He says, well, what about the lawyers? He says, I don't think lawyers do code reviews. Like, what are the lawyers going to do for you? Essentially, it was freedom of responsibility, which is core Netflix tenant, and essentially say, well, do you see a problem with it? And he said, no, then do it. There's no real problem with it. There's a lot of great examples of open source. The licenses are great out there. They're well established. Go Apache 2 out. That's pretty safe. So no, we had no qualms whatsoever. I believe pretty strongly that the more you're working on your resume, and GitHub is the modern resume, the more likely you are to stay, actually, at a company. It's when you think your resume is getting stale is when you start to look other places. So let people get their work out there. We're happy for people to do that and stuff. Yeah, so not a problem for us. Oh, sorry. Fred, you sort of.
The Asgard got a lot of great feedback from being used outside of Netflix.
Yeah, we get back contributions. I mean, it's not. There's really good messaging about pull requests. Pull requests is another way of saying, here's a bunch of my crummy code, please maintain it forever. So pull requests aren't free, but sometimes they do come with a lot of value, and they add to the value of the project stuff. And we've seen projects like Asgard, which is our cloud deployment tool, ported to other systems that we would have never thought to do and stuff. There's a lot of value to doing open source in general. Question back? Yeah, it's me and Rob, and I sit next to him. I say, hey, Rob, what about this? You think that's like a good idea? Yep, OK.
We want more.
Yes, hence the we're hiring. No, we've gone a long way with just me for a long time, and having Rob's been really helpful in opening up our bandwidth and stuff. But I think we're hitting a tipping point, right? As we recommend our clients, our users inside Netflix to use Gradle more, plugins is the obvious answer for them to add functionality, and we want them to get good at plugins. And so we're going to have to start providing a form of training, tutorials, that kind of stuff, best practices for them. It was fine when Rob started, and I just told him everything I knew in my head. But as we scale out, we'll have to add some more docs on stuff. But the beauty thing about Gradle, it's open source, it's out there, it's for everybody. Someone will write people have written books. They can leverage that stuff, and more stuff's coming all the time. So hopefully we don't have to do the training, or even if it was, we could hire people to do the training for those people. And I don't see a problem with that. That's the beauty of it not being our own custom internal thing, because that's the way it used to be. Any other questions? Cool. Thank you.